So today we're going to look at the curvature node in Maya and how we can use it to mix together two shaders on a single object. So in this case we're looking at this statue of Mercury, and I've got it with sort of a gold shader on it. In some places it's kind of dull, in some places it's a little bit shinier. So if we look down here at the rock he's sitting on, you can kind of see that in some areas like this, it's kind of dull where it would have been handled a lot, and then areas like this in these recesses, it's still shiny. So here we have clean Merc. Actually, this is inverted. This is the, let's call this outer Mercury. And so that is the shader that is applied here. And then we have, call this untouched Mercury, and that's the shader that's applied in these crevices. And the node that is handling the transition between these two things is called the aiCurvature node. And then all three of these are feeding into the AI mix shader. So the one shader is going into this slot, the other one is going into this one, and then the aiCurvature node is going into the mix attribute, showing Maya how to deal with these two different shaders to blend between them. So if we just take a quick look, we can isolate the aiCurvature node on its own, and if we just click here, we can see it's selecting in 3D these areas in white essentially, and we can use this transition from black to white to mix those two shaders together. So we'll just rebuild this from scratch in a second, but you can see you've got a number of controls here that are all about really controlling how far this effect spreads and its threshold. So here, if we just adjust the spread value here, we can see that it's tightening things up a little bit. And so you can see that the shiny gold is a little more recessed, and if we spread this out more, then you can see it's creeping out a bit. So it's going to be a combination of these different sliders biasing one way or the other, controlling threshold. And you'll see in some places, like, can we see it here? Let's take a look. I'm looking under his arm here. Yeah, so you can see as I turn that up, the space between here, this curvature, this recessed area is kind of leaking out down here. And we can also see sort of in his hand. If we adjust these, we can control how much of this other shader is visible. And if I go into the, not the outer, but the untouched Merc, and let's say we just turn its emission all the way up to bright color, then it kind of gives you a better idea of what it's doing here. So it's essentially looking for crevices or where there are surfaces close together. It's evaluating angle of change of the surface. So this little wrinkle in his belly here, down here we can see this stuff, and we can adjust these to increase or decrease the effect. So we'll just go down here and just select this region, so it'll be a little bit clearer to see. It's just reducing the radius here. So let's build it, and then we'll look at each feature as we go. Okay, So we'll build this again from scratch. So I'll create a new AI standard surface, and we'll call this demo outer, and then we will create another AI standard surface, call this demo inner, right? And then we'll create a mix shader, so AI mix shader. And then I think the way we want to do this is put the outer into shader 1. So I'll just middle mouse drag from demo outer and shader 1 of the mix shader here. And then demo 2, I'll drag middle mouse drag into the shader 2 attribute here. And so if we just change, the outer to this blue color and the demo inner to this, this is coat. So base color to red, and this one will change the base color to blue. And then we apply the mix shader to our model here and render. So it's combining those two, and we're getting purple, the red and the blue, right? So that's because the mix is just set to blend. You can also set it to add, so we'll add the two shaders together. But with the slider, we can go back and forth between the two shaders. So even this setup is quite useful if you just want to transition from one shader to another. However, you may want to use a texture or some other node to control mix weight. So just as an example, we could create an AI noise. And so mix weight is a single channel. So to connect AI noise to mix here in the mix shader, we can't connect out color because it's a triple channel trying to go into a single channel. So we can just take out color R to go into mix. And here you can see that the noise is sometimes letting the red show through, sometimes the blue, sometimes overlapping them. And so of course we can go in and change the qualities of this noise. So it's a little bit splotchier. Add more octaves to it. Anyway, so you see what I mean. So we can use any kind of node to control mix. And these can be animated, of course, if you want to change over time. So instead of using AI noise, just delete that. We're going to use a node called aiCurvature. Okay. And we are going to connect out color R to mix. And there are different ways you can do this, and I'll show you why in just a second. But if we render now with all the default settings, we can see that we're getting the red coming through on the convex curvature. So there's a curvature coming out, so ridges coming out from the surface. We're getting the red showing through, and we can see that particularly well down here on the edge of the plinth, and here on the sword, or whatever this is down here. I guess that's the staff. And so if we look in the aiCurvature node, by default, the output is convex. If we switch this to concave, now it's capturing the recesses. So the curvature again is being evaluated, but now it's being applied to the crevices rather than the edges that are pointing outward. So this already, the defaults actually give pretty good results here. Right, so Let's say we just, instead of using the gold, because that's a little bit difficult to see, maybe we just want it to be a little bit of a lighter red everywhere else. So, if this had been painted and the paint wears off, it will differentially wear off, but maybe be preserved in these inner regions a little bit. So I'll take demo outer and change it from blue to same red. So now they're both the same red color. But if we take the demo outer and just make its red a little paler, then you can see that some of the darker red is still showing through in these areas here. So it's much easier to see though if we have two contrasting colors. So if we just take a quick look at the aiCurvature node itself, so here you can see we can switch from convex to concave. So this is slightly confusing because if you look in the help documents, it says that when you connect these this node to something else, that the red channel is going to carry the convex, and that the green channel is going to carry the concave. But you see when I change it, it doesn't really make a difference. So I'll admit to not quite understanding that. And you can also connect, instead of the out color, if we go into here, there's also an output setting that you could connect to something here. So we can connect to mix, but it's connecting both the concave and convex at the same time. So there's probably a way to use this so you can take the output and then take the R and the G out separately from something else. So for now, it seems to work if we just connect out color R. And then the samples here, it's the number of rays. Oops, is it crashing? I'm just going to stop it. The number of rays that are fired to compute the curvature. I'm reading this from the help files. But the more samples, the cleaner the result, essentially. And then things like the radius and spread will control how far it goes. So let's just experiment a little bit. So the radius of the sphere around the shading point within which the curvature will be estimated. So smaller values show finer details, while larger values give a smoother result. So if we turn up the radius, it will smooth the transition out over a greater distance, but we'll lose some of those fine details. So if you go to 0, of course, you get nothing, but a small value will allow it to pick out these small details. So spread, it says, acts as a threshold to remove unwanted small variations of the curvature. So lower values will shoot more rays vertically with respect to the surface, and the default value of 1 means that rays are shot in all directions. So it must be the way it is tracking where the curvature begins, how sharp it is. So if we go too low, then it's not assessing any curvature at all. And if we go too high, if we go higher, it's spreading it out. So if we want to tighten it up, it looks like some value between 0.5 and 1. So if I get to 0.6 here, we're losing it. So we can spread this out a little bit. So we can adjust the bias again to, so if I turn this up, it's spreading the red out a little bit more. Then multiply is just what multiply sounds like. It's just increasing the effect. It's multiplying the values. So this is quite useful when you want to add what looks like wear or dirt on an object. So, we could make this demo inner the same blue but darker. or even black here, and it will just make it look, it's almost like an ambient occlusion pass at this point, but it's just filling in the crevices to reveal the detail a little bit more. I'm just going to turn up my light a little bit, it's a little dim. It's better, a little shiny, but now you can see that the black in here is helping to reveal the details a little bit more down here as well. And if you reverse this, I've used this before to on models that were meant to look like origami. So where paper is folded and bent out, the color is changing, maybe getting a little bit lighter. In that case, you would use convex. And so the outer parts here, an example like this, we would want this to be a little lighter because it had been bent. So I can just go into my, now demo inner is on the outside, but I can make this a bit lighter. So obviously this doesn't work with that origami idea, but you can use it to just preferentially assign a shader based on the curvature or angle and edges and crevices in a model. So it's a pretty easy thing to set up, and you can play around with the different settings to see what it does to control how things fall off and which part of the models get affected. So take a look at the help files, and I think you can use this to some good effect. Okay, thanks.